Okay, yeah, and I can email it to you after.
Yeah,
Okay,
that's awesome.
that sounds good.
Thanks.
Thanks, yeah. Okay, good. That works. Okay. Okay, hi again. Thank you all for coming, and hope you all are enjoying the Jason's Deli today. So to start off, I just have a couple of announcements. First is thank you all to those who came and volunteered for Girl Day. It was a really nice event, you know, volunteering and helping K through 8th grade girls, and we hope to participate again next year. So we hope to see more of you there. And otherwise, Data Hack, our Data Hack registration, we already have 17 signups, and we're going to cap attendance at 25 to 28 teams. So if you haven't signed up already, please sign up as soon as possible if you have your team of 3 to 4 people. And Data Hack, again, will be on March 25th, the whole Saturday, and we are providing breakfast and lunch. Does anyone have questions about Data Hack? Okay, perfect. In that case, for today's workshop, I'll be talking about Pandas, which is a very nice data analysis library in Python. So to access the resources, you'll have to go to our Instagram page, and I'll also send the Jupyter notebook that I'm presenting in our Discord channel, so you all can access it after if you just want to listen during this 1 hour. But if you want to follow along, the resources are on our Instagram. If you click this Linktree link, it should take you here, then click the top one, Pandas Workshop, and you should be able to see all 3 of these resources. The most important one is the notebook on the far right. The other 2 are data sets that we will be reading in during this lecture. So does anyone have questions or need help with that? Otherwise, like I said, you can just follow along for this workshop and look at it afterwards. Okay, I will go ahead and get started then. Okay. So first, this is a QR code for Freetail Hackers. I think they're having a raffle where you can get some prizes for filling this out, and they are having a hackathon this weekend. So please feel free to scan this. I'll leave it up for a couple minutes, and I'll also share it in our Discord channel after. Is the QR code working?
Yeah.
Okay, it's working. Cool. Okay, is everyone good with the QR code? Again, I'll share it in our Discord in case you missed it. Okay, so I'll go ahead and get started. Let me zoom in. Okay. In the back, are you able to read this generally? You can? Okay, perfect. It's okay. Don't worry too much about the words. I'll get to the code soon. But this is just a brief description of what Pandas is. But like I mentioned, it's a data analysis library in Python. And it's become the industry standard. So it's very useful library to learn, as well as scikit-learn. I will not be going over scikit-learn, but that's primarily used for machine learning in Python. So if you know Pandas and scikit-learn, you'll be in a really good place. So to start out, I will just go to the code. If you haven't used Pandas before, you might have to run this line here, pip install, which will install it on your local machine. And you'll just have to run this one time in one of your Jupyter notebooks or in your terminal directly. So how many of you have used or have Anaconda or some Python IDE installed? Okay, generally. Okay, if not, we'll also send some resources about that. But this lecture should be pretty beginner friendly. We don't assume any prior knowledge about pandas, so we'll just work upwards. So first you'll have to import pandas, and typically you'll write as PD, which is an alias for pandas. That way, when you're calling any methods in the pandas library, you can just say PD dot something instead of always writing pandas dot something else. So it's just convenient and shorthand. And then matplotlib.pyplot is used for plotting and visualizations. Oh, yes. The link to get these resources, it's in our Instagram under the link tree. So if you go to our MLDS_UT page, then click on Linktree, then Pandas Workshop. You should. Okay. Cool. Okay. Okay, yes. So you have to run these import statements and alias them with short names so it's easier for you to run code later on. Okay, so to start out, we're going to talk about two data structures called a series and a data frame. So are you all familiar with lists or dictionaries in Python? It's okay if you're not, but I think those might be you might have seen them before. So basically a series and data frame are just new data structures or things that we can work with in Python, just like a list, dictionary, or just an integer float. We have certain methods that apply to those specific types. And we're going to see some methods that apply to just series and just data frames. So to start out, we're going to write a dictionary here called data. So this is a mapping from keys and values. So apples in this case is the key. The values are 3, 2, 0, 1. So you can think of this as the number of apples that 4 different people purchased. And same with oranges, just the number of oranges people purchased. So then if you write data bracket apples, it will give you the value associated with this key. So a dictionary is very good for key value mappings, unlike a list. So a list is typically used for iteration, whereas a dictionary is better for these one-to-one mappings. You can just think of a dictionary like you look up a word in English and translate to Spanish or any language for that matter. And then this is a list just containing integers 0 through 4. Okay, so that was just to show you just general quickly list and dictionary, but a series builds on top of these. So to start out, I need to run import. Okay, so pd.dataframe will create a data frame using this dictionary I've passed in. So I'm passing in data as the dictionary and calling the data frame method from the pandas library. So this will create a column for each key in the dictionary. So apples and oranges are the two keys. Now they've become two columns, and the values associated with apples and oranges are listed in the data frame. So you can see here, apples and all the corresponding values, same with oranges. And the 0, 1, 2, 3 on the left side is the index for the data frame. So this is how we will access specific rows. And I'll show you that in a second. Okay, so now when you write this method, pd.dataframe, you can also specify an index. So I'm passing in the same data, apples and oranges, but now for the index, instead of the 0, 1, 2, 3, I'm writing people specific names, June, Robert, Lily, David. So this you can think of as June bought 3 apples, 0 oranges, Robert bought 2 apples, 3 oranges, and so on. So a data frame is just a simple table, and we often read CSV files from Excel as data frames in Python, which is what we're going to do in a little bit. So that's why if you all can download the 2 files, the new purchases and IMDb file, if you want to follow along. But again, I'll share them after so you all can run it on your own time. Okay, so now for accessing specific elements in a data frame, we use .loc, which stands for location, or .iloc, which is integer location. So .loc means we can specify a particular index and it will give us those values. So I'm just writing purchases.loc June, and it tells me June bought 3 apples, 0 oranges. And if you want more than one person, you have to add in another set of brackets. So now we're looking at June and Robert. So if you look here, when I just extracted June's apple and oranges, this is a series output. So you'll know it's a series if it looks like this, whereas this output is a data frame. And the difference is that a series is essentially one column in a data frame. And the series has 3 parts: the index, the values, and the data type, which can all be found very conveniently here. So the index are apples, oranges for this series. The values are 3, 0, and the data type is int64. And you can change that accordingly. So this will become very useful when you have a data frame where some of the columns may not be the appropriate data type, then you can cast it accordingly to resolve that. So yeah, basically a series is one column in a data frame. And then now, because I'm looking at 2 columns and for 2 specific people, it's outputting a data frame. And then another attribute here is D types, which will tell you the data type for each of your columns. So apples is an integer, oranges is also an integer because you can only have whole number of apples or whole number of oranges that you purchase. Okay, so now I'm going to get into reading the CSV file. So I have new purchases.csv saved in the same directory as this Jupyter notebook. So let me show you all what that means, because I know this can be a little confusing sometimes. Okay. So I know this might be a little hard to see, but this is my Finder. But you can see that I saved the new purchases CSV and IMDb CSV in the same folder as the Jupyter notebook. But had I saved it in another folder, you'll have to specify the file path. So you can just Google that if you want to search up file paths and all, but it's not too difficult to learn. And for a Mac, I don't know if you can see this, but at the bottom, I have users, then my name, then documents. This is the file path, basically. So you'll just keep writing / users / etc. And for Windows, I believe it's / and you have to start with C : : But if you search that up, you'll find a lot of resources about the file path. But that's just something to note in case it's not running for you. Okay. So Yeah, so now I'm reading in the CSV file as a data frame in this Jupyter notebook. And the read CSV method has a lot of parameters that are optional, but they might be necessary depending how your Excel file is set up. So right now you can see here when I ran pd.read_CSV, the index is appearing as another column. And this is not how we wanted it. We want the index to actually be the index, which right now it's 0, 1, 2, 3 in this data frame, but we want it to be June, Robert, Lily, David. So read CSV has another optional parameter called index column. 0 is the first column. So we're making the names of the people the indices so that when we want to look at the values for a particular person, it becomes easier this way. And if you search up pd.read_CSV, you'll see a ton of different parameters. Like if you look here, there's a lot of different parameters. So depending on how the CSV Excel file is set up, you might have to use these. I know like some of them, n rows you might want to use here if your Excel file is really big. Otherwise, your Jupyter notebook might take too long to run. So a number of rows just lets you specify like, I only want 10,000 rows within this Excel file. But I think this is easy to search up and read in case when you read in your CSV file, if it doesn't look correct, just look at one of these optional parameters to figure out what you need to change. Okay, I'm going to skip over this next part, but it goes over how to connect your Jupyter notebook to a SQL database, and you can actually write SQL queries in here. So that's one thing to note about pandas is basically everything we're doing in pandas, you can also do in SQL, but sometimes Python pandas will make more complex queries in SQL easier. So if you all have seen SQL before, like writing a bunch of different subqueries or going through all those steps can be quite tedious and hard to think about, whereas in Python, it can be easier. But sometimes for the really simple questions, SQL might be better. So it just depends on the problem that you have, but I'll show some examples where Python might be better than SQL. But basically everything you do in pandas, you can also do in SQL. Okay, so I'm going to move on to the next CSV file called IMDb movie data, which has the top hundreds of movies from like 2012, I think. So you can look here, it has Guardians of the Galaxy, Prometheus, and a bunch of different movies, their rank, genre, a lot of different columns. So it's always good to write .head, which will show you the first 5 rows in your data frame. You can also specify .head 3, it'll give you 3 rows, but this is just to, start looking at your data frame and know what columns you have and the values associated in the data frame. You can also use .tail to see the last rows in your data frame. And again, the default is 5 rows from the bottom, but I'm writing 2 here, so it'll just show you the last 2 rows. Okay. And then another handy attribute for data frames is .shape, which will tell you how many rows and how many columns are in your data frame. In this case, we have 1,000 rows, meaning 1,000 movies, and 11 columns or features that describe these movies. So that's good to know, just to know like how much data you have and how much you're working with. And then .info is very handy, and it will tell you the number of non-null values or number of null values and non-null values. So as you can see, we had 1,000 rows, and for genre, let's say, there's 1,000 that are not null, meaning there's no missing values. Whereas for revenue millions, there's only 872 non-null values, which means there's 128 that are missing. So we'll have to handle that later on. But .info is very nice because you can see all of this in one place, the column names, how many null values there are, the data type for each column. And object, you can just think of this as string or words, because if you look here, genre is like adventure, comedy. Those are essentially strings. For data frames, it's called an object data type. And then int64 is just integers. The 64 is how much memory it stores. And then float means it includes decimal points. So there are several data types, but you should always check that each column is the appropriate data type. Because this will matter for analysis purposes later on. So does anyone have questions right now about data frames or any of the methods, functions that I've talked about? I know I'm going through them a little quickly, but if you all have any questions. Okay. In that case, I will keep moving forward. So another function is .describe. This will tell you summary statistics for every numeric column in your data frame. Again, this is very good for initial analysis, just understanding your data. You'll see the count, mean, standard deviation, the spread for each feature. And you can also make plots, which is really nice. There's plotting at the end of this notebook, but that's always good to do for the initial analysis as well. Okay, so now I'm going to go over handling duplicate values. So in this movie data frame, I'll just tell you that there are no duplicate movies, like every movie is unique. But let's just say that, or I'm just going to create a temporary data frame here that basically puts all the rows of the data frame and just like doubles them. So it's duplicating every single movie. This is just to show you how to use drop duplicates later on, but some data sets will actually have like duplicate rows and you'll have to handle them. So basically this temp df has 2000 rows now. So like Guardians of the Galaxy here should also appear. It should appear again, basically, in the data frame because I just stacked the same data frame on top of each other. So now I'm just using drop duplicates, which will drop all repeating rows. In this case, every single column and row like has to match exactly to drop a duplicate. So like this Guardians of the Galaxy rank 1 action adventure sci-fi, that entire row needs to find another match for it to drop duplicates. So let's say I had another row that was like Guardians of the Galaxy, but rank was 2. That is not a duplicate row because it's not an exact copy. You can also write subset equals in here to drop duplicates on a specific column. So that's also just something to note if you want to drop duplicates for just one column instead of across all of them. Okay, so yeah. So now you can see I used drop duplicates here and the shape went back to 1000 rows instead of being 2000 rows like it was before. So it got rid of all the repeating movies. So this is another parameter that is useful to know called in place. And this will actually modify your data frame in place. So if I just, here, I'll go back and run the temporary df again here. So now I've added the same rows on top of each other. So there's 2000 rows. Each movie is repeating twice. And if I write here temp df dot drop duplicates, it will show you the data frame where the duplicates were dropped, but this temporary data frame is not actually modified, meaning now if I run temp df dot shape, it still has all 2000 rows. It didn't actually change this data frame. So basically in place equals true will drop those additional 1000 movies that repeated. Another way you can do this is just reassign the variable temp df equal to temp df dot drop duplicates. But in place just does that for you, so you don't have to reassign the variable. Does that make sense to everybody? Okay. Okay, so next I'll just go to some other attributes here. So dot columns gives you the names of each column in your data frame. This can be useful if you want to separate your columns by numeric or categorical variables or adjust them in any way. But you can also write dot columns dot values to have it as an array. And then if you wrap this as a list, this can be easier to work with sometimes. So now I have a list of all the column values. Because if you just write dot columns, it's in an index data type, which can be harder to work with. So that's why it's good to write dot columns dot values and wrap it in a list. But you don't have to worry too much about this unless you want to actually modify your columns or change them in any way. But this is just a good way to see the names of each of your columns. Okay. So, okay, now another method is dot rename. This will let you change the names of your columns. So in pandas, most of the methods once you see the name, it kind of makes sense, or you know what it's going to do. Like dot rename is going to rename the columns, but sometimes you have to be a little careful about small syntax things like rename. You have to pass in a dictionary like this with the, like, here, let me run this. Okay, so basically this is the initial name of the column, and now the right side is the new name. So it's the key value pair mapping. And when you write dot rename, it will basically change that column name to the one on the right. And in place equals true will actually modify the movie's data frame. So now, like runtime minutes and revenue millions has been changed to just runtime and revenue underscore millions without the parentheses. So sometimes this can be useful just if you want to change the name, or if it's not very informative, then that's helpful. And then this is a list comprehension. So this will basically iterate through every column in your data frame and make it lowercase. So that's basically for a list comprehension, this is the value you want outputted. Then you write for column in the data frame, and it will iterate through every single column. You don't have to worry too much about the list comprehension, but it makes code a lot nicer and more concise rather than writing out a whole for loop and like reassigning each column to be column.lower. So this is a very handy tool in Python. And then you'll see if you print a data frame, it's not easy to read. So it's better to just use df.head or just type df and run it so it's easier to read. Okay, so now I'm going to go over filtering a data frame. So let's say we only want to look at a specific year, in this case, 2014. We use the double equal sign to indicate checking equality, whereas one equal sign is for a variable assignment. So in this case, I'm just checking which movies have or were released in 2014, I think. So now the syntax for this, you have to write the data frame name, bracket, the data frame specific column equals 2014. So this is extracting all year values and checking which ones are 2014. So I can show that step by step so it's easier. So if I just look at the year column, it's outputting a series. So this is a series output, not a data frame. And we want to check which ones are in 2014. Because it's an integer, we can just write equals 2014. So then you'll see it creates a mapping of true and false. So Guardians of the Galaxy 2014 here is now true. Prometheus 2012 is false, etc. And then basically when you pass in these true false values to the data frame, it'll only keep the true ones. So you can see here, it filtered the data frame just to include every movie from 2014, but it keeps all the other columns the same. So that's good if you want to look at a subset of your data. And then if you want to add more than one condition, you can use the ampersand or the straight line, like vertical line bar. It's this symbol. If you can see that, just like the straight vertical line is for or, whereas the ampersand is for and. So ampersand means both conditions have to be satisfied for the data frame to be filtered this way. So in this case, we're looking for movies that are in 2012 and the genre of the movie contains action. Here, let me make this a little easier to read. Okay, so basically it's looking for movies in 2012 where the genre contains action. So this .str.contains just checks that this word action is within the genre. So in this case, Skyfall and Looper have action in there. And then I'm also adding a third condition where the meta score is greater than 80. So both of these satisfy all three conditions, but this is also really nice just to add more than one condition. And same with or, like if I did movies df equals 2012 or you should always put these in parentheses to indicate one condition, then the next condition on the right side. So this is checking either or. I'll just write the same thing like meta score greater than 80. So now only one of these conditions has to be satisfied. So in this case, Prometheus satisfies only the 2012 condition, but not the Metascore one, whereas La La Land satisfies only the Metascore one, but not the year. So just difference or an and. Okay. I have a couple of practice questions here if you all want to try them. There's just 3 questions using this data frame. And this is also from Strata Scratch, so you can look up the question on there, but you all can just like think about it for a couple of minutes, and you can talk to your, people nearby to think about these 3 questions, and I'll get back to you all in a couple of minutes. So, yeah, the notebook is on the link tree in our Instagram. And by the way, like I said before, you can do these questions in SQL and Pandas, but for now, let's try to do them in Pandas, but we can also talk about the SQL version of doing them too. Yeah, Nicholas knows. Nicholas knows. Yeah, let's say it's called DF. Yeah. Let me drink some water.
And single quote and square brackets. And it's just like not everyone is no, not that one, but like the two kind of I read it.
Wait, this is just the questions? Yeah, I'll put it out. Then I'll have to plug. So oh, I have that actor from that first movie. The one with Nicholas Cage. I think I have this.
Well, I mean, you said like, you know. Yeah, it's been, yeah. That's part of it. Yeah. It depends on what if you're talking about- I was going to this. Then I did I think early. It looks really nice. Including, sure. I want common between my.
Oh, you can, but then it becomes a project because the column is a string here. So you can't find the averages easily, you know what I mean?
Yeah.
You should pick what you need.
Isn't that important? Like maybe credit. Not like the thousand. Yeah. Yeah.
I'm just tired of talking.
Well, I'm trying to do my sales now. Oh.
Oh.
Honestly, I think it's your cost.
Oh, yes.
I just want to see
Okay, I hope y'all were able to figure out these 3 questions. Does anyone want to volunteer or talk about the first question? Anyone have any thoughts about how to approach it? Even if you don't have the exact syntax, just like, how would you solve this problem? Yes.
It's like that use filtering the data frame. So search for the department code for Aston, and then UTF square brackets and filtering, and then you take it away.
Nice. Okay. If y'all didn't hear that for the first one, we had an excellent volunteer. Oh wait. This is how I would think about the first question. I'm not scrolling down because I have the answers to the next 2 problems, but basically you'd filter the data frame, looking at the department column and checking that it matches admin, since we're only interested in the admin department. And then LEN tells you the number of rows in your data frame. So that will tell you how many employees work in the admin department. And also in SQL, you could have done this just using like select count all from the table where department equals admin. So in this case, like you can see that like the syntax, the ideas are the same between SQL and pandas. The syntax is just a bit different. So SQL might be a little easier to understand, but I think it's worth learning pandas because the more complex problems, I think it's easier. So does anyone have any ideas for the second question? Any thoughts about how you'd approach it? Any ideas? I didn't go over this exactly, so it's okay. Yes.
Is the work ID an integer value?
Yes, yeah.
So would you do modulus 2 if like modulus 2 equals 0?
Yeah.
Like and maybe
Yes, that is right. So if you all didn't hear that, to check if something's even, we'd use the modulus operator, which is the percent symbol, 2. So we're dividing by 2 equals 0 to check that it's equal to 0, and we'd filter the data frame accordingly. So in this case, we're looking at the worker ID, mod 2, checking that it's 0, and we would get just the worker IDs that are even. If we wanted it to be odd, it would be equals 1. So, okay, for the third question, any ideas? Yes. Yes, we would use a condition. And does anyone know how to negate a condition? Can find that, because I think it's easier to use a negation here. It's okay if you don't. Yes. Yes, the exclamation works. I actually use the tilde, but yes, the exclamation is also a negation. So in this case, I'm doing df first name dot is in. So this will just look at this first part. Dot is in checks that the first name is one of these, and then the tilde just negates the whole thing. So we're looking at first names that are not Monica or Vishal. So then I'm just filtering the data frame to include all the other names. So yeah, those are just a couple of practice questions. There are more difficult ones on Strata Scratch if you're interested in, learning more about different applications. So does anyone have any questions right now about anything in pandas? Okay. If not, I'll go over how to work with missing values now. So you can just write your data frame dot is null, and this will give you the data frame back, same number of rows, same number of columns, with false and true for if there's a missing value. So in this case, like we saw before with .info, there were not many missing values, only in the, here, I'll run it again, actually, so y'all can see, but only the revenue millions column had, and Metascore had missing values, because this tells you the number of non-null values. All of them are 1,000, and there's 1,000 rows, except for revenue millions and Metascore. So these have some missing values, and we need to handle them. So dot is null just shows you true here to indicate that for this specific movie, Secret in Their Eyes, revenue millions has a missing value. So they didn't capture that data for whatever reason, and we need to figure out how to fix that. So you can also write dot is null dot sum to tell you the total number of missing values in each column. And this is just like we saw with dot info, same information, but instead of non-null, we have the missing null values now, the number of them. So one method here is just dot drop NA. This will remove all missing values. So the problem with this is you'll lose a lot of data. So if you think about it, this true value here, only the revenue millions column has a missing value here, but nothing else is missing. So if you use dot drop NA, it will remove that entire row. If there's even one missing value in one of the column row pairs, it just gets rid of that entire row. So you can imagine that you're losing a lot of data that way. So we need to find a better way of handling these missing values so we don't lose too much data. Okay, so basically, instead of dot drop NA, we can use imputation techniques. So you can replace the missing value with the average for the column, for example, or the median. So those are very simple imputation methods. However, those are actually not the best either, but it's certainly better than just dropping all the missing rows. So at least if you replace the missing revenue millions with the average for all movies that have a revenue million value, it's better than dropping it entirely. So here, I'm just looking at the revenue column, and then we find the mean 82.96. So now we can just do revenue.fill.na with the mean in place equals true. We'll actually modify the series in this case. And now you can see if I write dot is null dot sum, this changed from 128 to 0. So there are no more missing values in the revenue millions column. And if we take a look at the data frame, everything that was missing, if you remember, the Secret in Their Eyes movie had a missing for revenue millions. Now it's replaced with the average, 82.96. Yeah, so now if you run dot describe, it will change the summary statistics for that column now that we've replaced the missing values to accommodate that. Yeah. And then another method here is dot value counts. This is especially useful for categorical columns. So in this case, it tells you the number of movies that were action, adventure, sci-fi, number that were drama, and value counts looks at unique genres in this case. So like it gets each unique genre as an index here and the number of movies that had the entire value here, action, adventure, sci-fi. So this is really good just to look at counts. However, value counts is not very useful for float columns, because if you think about like a column that has a bunch of different floating point decimals, like miles per gallon for cars, it can be like 20.1, 20.11, 0.12. So if you write value counts, it's likely that each value will have a count of 1. It probably doesn't repeat that often. So value counts is primarily used for categorical features. And then you can also use .core. This will give you the correlation between all your numeric variables. And as you can imagine down the diagonal, it's all 1 because rank is perfectly correlated with itself, year, etc. But this is good to check for the problem of multi-collinearity. If two of your features are too correlated to one another, you don't want to have both of them in your data set. You want to get rid of one. Otherwise, it's not adding any more variation explained in your data set. Okay. And then just writing type, as y'all have probably seen, type tells you what data type it is in Python. You can look at subsets. Okay. This is just more filtering in data frames. So I'm going to skip over this part. Okay, so now there are two functions called .apply and .map. We use .map to apply a function to every value in a series, meaning for one column of a data frame, we'd apply some sort of function. So I can show you all that right now. So let's say we have movies data frame and we want to subtract 1 from each runtime. Let's just say that's what we want to do. You could write 2 for loops and iterate through every single row, column, pair in the data frame, but that's quite tedious. So we can just use .map and write a function here. So, oh, and I should specify the column runtime. So you can see here, this first runtime is 121. Now I'm just applying this lambda function to this column. So now if I run this, you can see it went to 120. It subtracted 1 from each value. Yes.
Could you also do like movies df runtime is equal to movies df runtime minus 1?
Yes, I
Is there a
believe you
reason
can do
why
that.
you would use that?
Yeah, because instead of just subtracting by 1, the functions could get more complex. I think that's mainly the reason. And also, actually, let me just check. I'm pretty sure you can do that though. You should be able to. This is what you're asking, right? Or I think now it'll subtract, or it should just subtract 1. Yeah, that did modify it. So yeah, instead of just using .map, you could write it like this, like reassigning the column runtime to runtime minus 1. So this subtracted 1 from each value. But .map, I think, is preferred, which will iterate through every single value. So yeah, it basically just goes through each of these values in runtime, like 120, 123, and .map applies the function that I wrote here. So instead of writing a lambda function like this, you can also write out a function def, whatever name, and then write out like x, return x minus 1, and then pass in the function name to map instead of writing a lambda function like this. But this is more concise for something simple. Okay, and then .apply is similar to .map, but it works for an entire data frame. So .map is only used for a series, one column in a data frame. .apply can be used for an entire data frame and apply some function to every single value. So in this case, we're just applying a rating function. If it's greater than or equal to 8, return good, otherwise return bad. And then just applying the function. So now we have rating category here, good and bad, instead of the numeric value for rating. So everything that was 8 or higher is good, everything else is bad. So you could write it the same way with the lambda function instead of writing a separate function like this and passing it in apply. Yeah. Okay, here's some plotting, which is really nice, especially for initial analysis, just to see the spread of your distributions. Typically for numeric variables, you want to find a histogram. So you can just write the data frame .hist for that column. So I can show you that too. Like for the rating column, I can just do .hist. Oh, I spelled rating wrong. Okay. Yeah, so you can just do .hist and you'll get a histogram for the numeric variable, and you can separate your data frame into numeric categorical columns and write like a for loop if you wanted to show histograms for every single numeric variable. That's something useful just to see how they're distributed. So just to get a feel for like left skewed, normally distributed, right skewed, it's good to know that. And then this is a more complex plot. Scatter plot just between rating and the revenue in millions. Sometimes you want to see how related 2 of your variables are. So that's good to know as well. So yeah, I'm going to stop here because I know it's almost time. So does anyone have questions about anything? Okay, if not, thank you all for coming and I hope you all sign up for Data Hack. And yeah. Cool. Yes.
Now it's not.
Unplug this. Oh, let me stop recording.
Yeah, also, I wasn't planning on having meetings today.